Good morning and afternoon, everyone. Welcome to our Wednesday Fast Track Hangout. I'm Wayne Griffenberg, a CAD/CAM applications engineer at Autodesk, and today we're going to talk about our Fast Track to CNC programming hangout today. Fast Track to Autodesk University. So our Fast Track program is really here to help people like yourself who are new to Autodesk CAM and CAD, working all the way through from your napkin sketch to go all the way through, design up a part, being able to put your CAD and your CAM together to be able to get that code out to your machine. Just to let you know, we have some seminars that happen across the country. Live classes at our partner centers as well as our education centers. HFO shows going on throughout the year, as well as other partners who work with Autodesk. So these live seminars are there to help you get a hands-on idea of what it means to work with our CAD/CAM interface, to set up a part, put your CAM on, and run it on the machine directly. We also have these Fast Track Wednesday webinars that we do to help get you started, as well as Friday webinars, as well as Pluralsight training. You get 30 days access to Pluralsight trainings that were created by our elite users, our partners, resellers, where you can download the parts and walk along with the live presenter, as well as pre-recorded training that you can access through Pluralsight. So this gives you 30 days that you can sign up on our Fast Track program to get started with working with our CAD/CAM interfaces. So this all leads up into Autodesk University. All those classes that our elite users and our partners are creating, you can see them live at Autodesk University. We have some classes going on the first day to take you all the way through the product innovation platform, to design an enclosure that you can 3D print as well as machine and walk away with a speaker that you can plug into your smartphone. So that takes you all the way through development, to design, to making a part. Then we also have our full track of CAM classes. We have elite users within Autodesk as well as power users in our community who have created classes to help you become more successful and drive your business and grow in CAM, multi-axis, and to the future of CAM, don't fear 5-axis, advanced post-processors. Attend those classes and meet and work with those power users, as well as a CAM Fast Track to get certified in being able to walk through every gamut of our CAD/CAM interface inside of Fusion as well as inside of HSM. So that's at Las Vegas this year, November 14th through 16th at the Venetian. Just to give you a kind of a sneak peek of the speaker that you would be making in that initial class for product innovation platform, working with our Eagle integration to be able to make a PC board. You're going to 3D print out part of that enclosure. You're also going to CNC the base for that as well. Here's our certification working at Autodesk University, so I highly recommend joining us there. You're able to meet with people like CJ Abraham and Angelo Juras at Pier 9, and we see them every day on Instagram, some of the amazing projects that they're working on at Pier 9 in San Francisco, as well as Kevin Lee and Kevin Ellingson, who work with our partners. And they do a great job of teaching those classes in a nice, easy to learn way, as well as Derek Goodwin, who works with our HFO in California. So that's going to take you all the way through the basics and getting certified with Autodesk through Autodesk University. Some of our speakers, we've had John Saunders on our webinars, as well as Rob Lockwood. We call him Rob Awesome Lockwood, and he is from Oculus. You can see a lot of the projects he's been working on, as well as teaching classes and speaking at Autodesk University. John Saunders, Seth Medora, Lawrence, and Amish, you see them in our forums. They're the power users that give us the answers when we run into problems with setting up our Toolpaths, being able to design our parts, getting good parts off our machine. As well as you can meet our product manager as Al Watmo and Renee. And you see them also in our forums as well as in Instagram and some of the cool projects that they're working on. Marty Deans and Tim Paul on our adoption team. And Lars Christensen, who does a tech talk every week. And you could meet them live. It's a great chance for you guys to network and meet these guys and be able to learn from them firsthand. So I highly recommend joining us at Autodesk University this year. It's going to be very CAM heavy, and it's all part of our Fast Track program. So you can get started now. If you join in, you'll see access. You'll also get part of that challenge. With that, today, this webinar we're going to do today, we're going to talk about basic turning inside of Fusion. So we're going to go through our Fusion team. I'm going to give you a quick overview of some of the hubs and projects and how to work with it. And to talk about our basic drawing, we're going to make a part, simple draw up a pulley part and model it. And then I'm going to do oriented for basic 2-axis turning toolpaths. So I'm going to show you how easy it is to walk through those toolpaths and set it up to get the parts off the machine. Before we do, we're going to simulate to check and verify the parts or the toolpaths that are going to work to be able to get the parts off your machine, as well as we're going to get some code. And I'm going to make a design change, and I want to show you how that integration works from the CAD to the CAM side. Okay, this is the basic part we're going to draw up, a simple pulley and revolve it around. And then we're going to put some toolpaths, some contour toolpaths, a facing toolpath, grooving toolpaths, and then we'll even get a boring bar to show you how to bore out the internal components of the part. So that's what we're going to do. So let's just jump right into it. I'm going to bring you into Google. So I'm going to log into my project. So I'm going to go over to this Fusion team. When you start to work with your projects, you're going to get into a hub. And in the hub is where you're going to save. You're going to log in and save your project when you initially start working with Fusion. I have some projects here that I'm working on, as well as I can see activity of what's happening in those projects. Some of these are shared with me, some of them I share with others. And they were able to invite me as I walk through. I can go in and log in and see some of the parts. And when you invite somebody to your project or your hub, you can control the access of what they have, whether they can create projects, edit parts, change parts, or even upload parts into your project. So I'm going to jump into this fast track to CNC programming. And these are some of the parts we did last week. And I can also see that the project member is me, and I can add and invite others simply by putting their email in here to be able to send out the link that they can add through their email. I can add them into this project. They can join in, and I can manage what level of access they have. I can also see these projects in a different way. If I go into the grid view, I can see I have some folders here as well, and I can also see I have some parts that we worked on last week. So we downloaded this vise. We're able to turn it into an assembly inside of Fusion, and we're able to bring this part. We created an adapter plate for going from a carburetor to an intake manifold, and I was able to bring it into that assembly and machine it. So that's what we worked on last week, and this week we're going to do our turning part, but I just want to jump in here just to give you an idea of what the overview looks like. So I'm going to jump in, and I can see the template that we used that I created. There's the vise. Here's the part that goes into it. You can see your where used, your drawings, and any renderings that you may have or may have made of that assembly that you can share on your website, on Instagram. You can even send it to some of your customers or even your colleagues. So if I go even further, I'm going to go in and look at an overview of this part that we're working on. I can go right into my browser and I can see the components, I can see the assembly, I can see the part we're going to make. I can change and access and be able to see different views of the part. And again, I'm only in my browser here. So if I want to find out what the part's made of, I can simply go into properties, select the part, and I can see it's made from steel. I can see the volume, area, density to get some good idea of what the part's about. I can get some quick dimensions. So if I want to see what's between, let's say, this hole and this hole, I want to know what that dimension is, I can easily find it right here inside the browser. If I wanted to get a section view, I can easily do that too. I can say I want to add a section view through the center plane here. I can drag it and I can see what's going on, let's say, inside of those holes right there. I can even see a different angle in that section view, and I can just flip it around like this and I can see it right in the view inside of my browser here. So I can turn that off. I can also go and do an exploded view. So if I want to explode out and I want to see what the assembly is made out of, I can easily do that. You could set yours up if you want to look at the functioning or what's inside of one of your components or your assembly. You can easily do that here as well. And again, I can share this with anyone. I can select, if I want to go up to say, I want to share this, I can just simply go up to share, and I can send a link to a customer, to a colleague, to anybody I'd like to come in and see what this looks like, simply by sending them, copying this link and sending them. I can choose whether I want those the people that I'm sharing it with to be able to download to their computer the assembly, and if I do, I can also choose to have them put a password in that they'd have to plug in before they can download it. Or you can simply turn that off and allow colleagues to be able to download freely or get into the project. So I'm going to close that out. There's also ways, if I want to export, just to let you know, you can export to many different file types right from this browser view. It'll export that assembly out as different archives and different types of exported data. If I wanted to edit it, just to let you know, we do have the preview where you can edit right inside the browser. It just adds flexibility of you to be able to design. Say you're not in the office, you might be on your iPhone or your iPad. Well, actually, in this case, you wouldn't be able to edit it on your iPad yet. But if I had a Mac, I can open it inside of my browser on the Mac, or I can open it on my laptop if I'm away from the office and edit, do basic edits on the parts, and be able to add that so my colleagues can see it. So when I get back into the office, I can save that idea. So it adds flexibility. But right now, it's only in our preview mode today. I can also edit on the desktop, which we're going to do here. So I'm going to go and click Edit on Desktop. So I'm able to bring it up, and now if I don't have Fusion installed, if I'm on a PC or a Mac, it gives me a chance right now to download and install it. Now I do have it installed, and it's opening in the background. So it looks like I was working on this before, so I'm going to close out. I had another assembly open. I'm just going to say OK. I'm going to continue, and it's going to go and open up that same assembly that we were working on inside of the Fusion browser. Or this isn't the browser, the Fusion desktop client. I'm going to change my view real quick, my visual style, just so you can see. I'm going to go into Visual Edges like this. And you also see it has an update. That means my part has changed since I opened this last. And I can click that update and it'll update the part. But today we're not going to work in this assembly. We're going to create a brand new part that we're going to turn on our lathe. But I just want to show you that we can get from the web interface directly into our client, our hybrid client, right on our desktop. And I can continue to work in the CAM on this part. I can also go and change any of the aspects of the model really quick. So right now I'm not going to update it. I'm going to close out of this assembly, and we're going to start from scratch to make that pulley part that we have on our napkin sketch. So I closed out and I'm starting fresh. This is our canvas view. I'm working in the model workspace. And in the model workspace, I have on the ribbon bar all of the features and all those tools that you would be used to working in a 3D interface like this to be able to create parts, create sketches. You can modify, do direct editing right on the part if you uploaded a part. I can show you that as well. And also if we're working with assemblies and how we can apply joints to mimic what's going on in the real world in our assembly. We can also create from primitives, but we can also create form parts. This is our T-splines where you can mold like you're working in clay and then make that become a solid that you can then machine and work with later on. So I'm going to go and start a sketch. I'm going to go into view down here first. Before I start the sketch, on my browser, I have the ability to change whether I'm working in inches or if I want to change that over to millimeters, I can do that really quickly. In fact, you can do that anytime during the design, and it's flexible and it'll switch your measurements over even in the CAM interface as well. So here I have some views that I can quickly move to as I'm working through the model. And speaking about views, I also have the view cube up here that I can also manipulate and move around to get any view that I want. And you notice it also gives us the X, Y, and Z axes, so we can see where it is on top, front, or right of the part, and all the way around the view cube. I'm going to expand this down a little bit because I can also show the origin. We have it turned off now by default. That little light bulb I can turn on, and you'll see all the axes really quick. You'll see the planes as well as the axes, the X, Y, Z axes that we can work on. And also down here, I'm going to have a timeline. So as I start to create sketches and bodies, you're going to see it expand on the timeline here. And we can always go back in time to make changes that we need, keeping it very flexible in this interface. Okay, so the first thing I want to do is I want to set up to do a turning part. Now, I recommend it. You don't have to, but I like to put this view into position the way I like to see it on the machine. And we know it's different on a turning machine than on a mill, where our Z is going to be our center axis of revolution. And generally most machines, I shouldn't say all, but most machines, unless you're working on a VMC or not a VMC, a VCS, you would have the Z axis being the center of revolution and the X axis positive. So you're going to work on the XZ plane, and that's what you're going to revolve around the z-axis. So that's the way I like to set it up in my view. So I'm going to work on that same plane. So notice as I highlight that plane, it also highlights in the browser as well. So I can easily go in here and right-click in the graphics view and start a sketch, create sketch by right-clicking on the view. I can also right-click in the browser. I just hit escape, but I can right-click on the browser and create a sketch, or I can also go up here and create a sketch and then select the plane. So it's very flexible in the way that you like to work to be able to get started sketching on a plane. So I'm going to do it right from here from the graphics view. I'm going to right-click, create sketch, and it brings me into that view. So I'm going to work in this quadrant where my x-axis is positive, and I'm going to revolve around the z-axis, and this will be my 0, the front of the part. Notice when I created the sketch, it also gave me a folder here with a sketch in it, and also in my timeline I have the sketch we're working in. It changed over to a grid view, and as I start to scroll out, you'll see the number lines start to change as I scroll out, so I have a good idea of the space I'm going to be using to be able to generate this part. So the first thing I want to do is I'm going to create a rectangle that's the base of the part, my stock if you will. So I'm going to start with a rectangle. So I'm going to go up to Sketch. I can pull this down and go to Rectangle, and I have some options on the type of rectangles I can make. A simple 2-point rectangle, I can hit the R key on my keyboard, or I can select the 2-point rectangle. Notice when we do have keyboard shortcuts, you can see it right here for trim, for offset, for line. But I'm going to use the rectangle. I'm going to go click 2-point rectangle, and when I do, it brings in, let me move this real quick because it looks like one on my other screen. Here we go. It brings in this sketch palette. So as I'm working in this interface and I started a rectangle, it brought in on my sketch palette the rectangle feature here. So I still have a chance to be able to change that over if I want to. But I'm just going to start the 2-point rectangle, and I'm going to hover over the origin. Notice it snaps into the origin. If I start to drag, you see it rubber bands this rectangle shape. So, and it also applies to it some dimensions that I can plug in dimensions. In this case, the length I want to be 3 inches. So I'm going to plug in 3, and I'm going to hit the Tab key, which locks in that dimension. I'm going to put that little lock on there, and it went over to my x-axis dimension. And I want this to be 3 inches diameter, so I'm going to give it the radius. I'm going to say 1.5 and hit the Tab key again, and that locks it in. So now I have a locked rectangle with it's 1.5 by 3, and no matter which quadrants I roll around, it keeps that locked in. So I can choose the quadrant that I want that rectangle to be in. So I'm going to select this quadrant here. I'm just going to click there, and it now gave me this boundary area. This is a 1.5 by 3 boundary that I'm going to revolve around the z-axis. But notice it gives me this region. So as I hover over it, I can click it and it changes and it selects the entire region. I also have these constraints. So it added constraints in here as well. So I have horizontal and vertical constraints automatically added because it recognized the way I'm drawing on these axes here. So if I ever want to change them, I can easily go and delete out. I can select the constraint and delete it, and now I can add an angle there if I wanted to. Now I can easily add it back. I can add coincidence, or I can even add other types of constraints to the model. If I want to make it perpendicular, these lines perpendicular, I can easily add that in. And in this case, I'm going to hit undo because I did want to have that vertical constraint there. Okay, so now that all my lines are black here, that means I'm fully constrained. I'm able to now create a body. So I'm going to rotate this around the way I like to see it revolve, almost like an isometric view here. I can also do this and select this corner of the view cube, and it snaps and makes that an isometric the way I like to see it. Okay, so I'm going to revolve this around the z-axis. So I'm going to go up to Create, and I'm going to go create a revolve. So I select Revolve, and it brings me into this view. Now notice I didn't have to get out a sketch. I didn't have to exit the sketch. I just went right up to the feature and said I want to revolve it. So the first thing it says is, what's my profile? I don't have to select individual lines. I just select that face right there. And then the next thing is, what's my axis of revolution? Now if I drew a line, I can easily select that line. I can also select the origin, the axis of origin, this z-axis, and it revolves around that z-axis. It creates a new body. But I have some choices where I can join or cut, but there's no other bodies to cut from, so it just created a new body. I'm going to say OK, and now I have this body here that we can work with. So now that's going to represent the base of the part, and now I'm going to go back in, I'm going to draw in another sketch the features I want to cut away for the pulley. So really quickly I'm able to go in and create some geometry, revolve it around, and now I want to go and add another sketch. This time I'm going to go up to Sketch, What Plane? I can even select the plane right off in the graphics view, in the canvas view, and now I'm in this plane in the sketch back where we were before. This time I now have a body, a revolve body on my timeline. I also have this new sketch that we're creating as well as the sketches and bodies in my browser. Now I can start sketching in here with a line, but the body might get in the way because as I start to click and I start to work, I see it highlights the body. If I'd like to hide that, so I can easily hit the light bulb and it keeps the body, now it hides it, so I can continue working on my sketch. Notice that also both sketches are turned on. If I turn off the old sketch, it turns off the old geometry. I'm working in this new sketch here, but I want to borrow geometry from that original sketch. So I'm going to turn it on and I'm going to project these lines into this new sketch. Now I can hit the P key, I can go to Sketch, and I can go down to, where am I? Oh, I can go down to Sketch, Project Include, and hit the P key for project. That means I'm going to project that geometry from the old sketch into this sketch. Now I can do it that way. I can also right-click in this, we call this the marking menu, right-click in the graphics view, go down to this sketch feature, and I can project by going my cursor down to about 5 o'clock here, maybe like 4:30, 5 o'clock. And notice it touches that project. I can do it this way and get right to that same feature. So you can always right-click and get to the functions in the masking menu. So I want to project those lines. It brings up the project tool right here. So now I'm going to project this line and it turns pink. This line, this one, and this one. And now I have a region and it projected those 4 lines. Now I have a closed region. I'll say OK, and I'm going to turn off the old sketch. So if the old sketch does change, so will my new sketch will change parametrically with it. Okay, so now I have the basis of the profile. I'm going to draw my features in here. I'm looking at my napkin sketch on the pulley, and it looks like I have a bore going through, so I'm going to start to draw that. So again, I can hit the L key to start a line, or I can go into my sketch palette here, and I can choose line. And remember, we can also do the right-click, go down to sketch, and now I can go and choose a line. I can go straight down 6 o'clock, and that'll give me a line. So it remembers the gestures. So as I'm working, I'm going to do that a couple times. So it makes it easier than having to click and choose, where you saves you click, where you just right-click, pull down what you're looking for. So now I have a line cursor, or shall I say a line function attached to my cursor. So now I'm going to hover over, and notice as I hover over other lines, these projected lines, it gives me that snap, the intersection snap right there. And also if I go to the midpoint, it gives me the triangle for midpoint. So you can learn a lot more about these constraints if you go to our Autodesk Knowledge Network and do a search for constraints in Fusion 360. It'll give you a lot more background on how the different constraints work. So I'm going to snap to this intersection. I'm going to draw arbitrarily. But notice as I start to stretch a line, it's now snapping to perpendicular to the line I started with. Okay, and I can choose a dimension. I can plug a dimension in here. I can also give it an angle. But I'm going to freehand draw it the way I have it on my sketch. Later on, I'm going to add constraints, and then I'm going to add dimensions. So I can lock down the constraint and can fully constrain this sketch. For right now, I'm just going to draw it by eye. So I'm going to click there. I get this green check if I want to complete the line, but I want to continue. So again, if I start to go perpendicular to that line, it gives me that perpendicular constraint. I'll do the same thing, and I'll go up till I finish and terminate at that top line right there. But notice it gave me these constraints automatically. These are the perpendicularity constraints that automatically put on and recognize that I want perpendicularity in those lines. I'll do the same thing. While I still have a line command functional, which is another great thing in Fusion, even though it terminated, it still gives me the chance to continue the line function. So I'm going to select an area right in here, and I'm going to do this, it's actually a threaded feature, a threaded boss that I want to have on the front of it. that leads up to my flanges. So again, I'm going to draw it like I see it on my napkin sketch. I'm not putting anything exact in here, but I'm going to draw up to my first flange right there. So I'm going to hit escape while I'm here, and I just want to show you. As I was drawing these features, I have a closed boundary, but I didn't have to intend and finish this off and draw other lines. If I hover over, you see I have a boundary that I can select individual boundaries to work with. And that's one of the great things about Fusion is that once you close this, it doesn't have to be a completely closed boundary. It recognizes automatically that as a section that we can work with. So now I have 3 individual boundaries or regions that I can work with to model. I'm going to add one more, which is the flange between the 2 flanges in our pulley where our belt's going to ride. So I'm going to go up and add a rectangle. Again, if I right-click, go down to Sketch, and in Sketch, if I go up to about 2 o'clock, I have a 2-point rectangle. And this is a neat thing. You don't have to wait for it. If I did this and drag down then up, it gives me a rectangle. You see it attached to my cursor? You can do gesture. If I go down and then down, it gives me a line. Rectangle up, 2 o'clock, it gives me the rectangle. So it's really a gesture control. You can quickly get to your functions just by using gestures like that. So that was a right-click gesture. So I'm going to snap here. I'm going to drag this rectangle down, and that's going to be the pulley section in between where my belt's going to ride. So again, now I have 4 regions in space. We're not locked down. If I drag any of these corners, you see our blue lines are telling us that we're not fully constrained. So now I want to constrain these. So the first thing I do is now I want to dimensionally constrained. I often like to work when I do turn parts is work from my datum out to the diameter first, and then from my 0 point back, from my datum back. So it's just a habit. You don't have to, but it's often a way to control your dimensions as you're working through turn parts. So I'm going to hit the D for dimension, or again, I can go right-click down to Sketch, and our dimension is at 9 o'clock. So as you start working with this, you should kind of remember where these functions are. So I can easily go right-click down, and then over 9 o'clock, and I'm on dimension. Of course, I can always hit D on my keyboard. But let's start this. So I'm going to go from my datum point out to the center of where this bore is going to be, and that is actually going to be 3/4. Wow, I did pretty good. That's going to be 3/4 in diameter, so I'm going to make that 3/8 dimension here. Again, it still keeps my dimension mode on. I don't have to exit this, so I'm going to go from my datum point out to where my bored out section is. This is going to be my front bore inside of the threaded housing. So this will be actually 0.625. So I'll go 5/8, hit enter. So I'm able to plug in those dimensions, and as I do that, notice the lines are turning black. So they're being constrained in the position where they're at with the dimension. I'll do the same thing here. Oops, I think I might have selected the dimension instead of the actual datum. I did it again. Try it this way. And now I'm going to make this one 3/4 of an inch. Same thing here. I can also grab this line here so I'm not grabbing the dimension edge. And this is going to be 1 inch. Okay, we're almost there. And now I want to be able to get this dimension for our pulley here for the belt area. Let me go and put that. And that's also going to be 3/4 of an inch. All right, so I'm working from now the datum back, my 0 back. So in my bored out section right here, I'm going to go from the datum. I can grab the line to this edge. And that is also going to be, that's going to be a 1/2 inch. Okay, and this edge is going to be 3/4 of an inch. And now where my flange is going to start, I'm going to zoom this back. And my flange is going to start at 1 1/4 inches back. Actually, I want that to be 1.5 inches. So I'm going to go and make this one from here to here. That's going to be 1 3/4 inches. And I want a 1/4 inch flange, so I'm going to change this one. All I did is double click on it. I'm going to make that 1.5 inches. Now I have a 1/4 inch flange in the front. I'll do the same thing here. I'll select this one here, and I want this to be 2.75, and now I have a 1/4 inch flange in the back. Okay, so now I'm fully constrained. I'm going to hit escape, and I have these regions to work with, and now I don't have any more blue lines, so I can't drag them around. I'm completely constrained, and I'm working from my datum out and my datum back. So now I want to revolve this. Now I want to show you we can revolve the same way we did before. So I'm going to rotate this around. I'm going to go up to Create a Revolve. And now if I select these regions that we want to cut out, I'll select these 3 regions. And it's easy to select regions right out of the sketch in the graphics view. And I want to revolve that around the Z-axis. And when I do, it gives me a new body, right? And I know I have like these 3 bodies floating in space kind of here, but it's going to give me 3 bodies because it doesn't see anything to cut from. We did our initial body here. If I turn it on, it now recognizes that there's a body there and it switched it over to be a cut. Really smart how Fusion recognizes those bodies. But of course I can join it if I want to have a multi-body model, intersect. But in this case I do want to cut away. And I'll just say OK, and now I have the net shape of what we want to cut on our turn machine, on our lathe. So I'm going to hide that sketch for a minute. So we have this net shape, but what I'd like to do is I want to be able to get some radii on here. I have 30,000 radii all the way on all these edges, these transitions here. So I can easily go up and I can start to do a press pull. Now this is a direct editing solver that we work with. Like in other words, I can grab this face and start to press and pull it, and you can make a dynamic change that way. It's parametrically saved in the history when we do that, but it doesn't match the sketches and what we were working with. So I don't really want to do that at this point. What I do want to do is I'm going to add a fillet. So I'll show you a trick. If I grab this edge and I can start to pull this down and make a fillet, and I can easily make that 30,000s, and I can start grabbing other edges. But here's a quick trick for you. If you want to make all these edges and have a radius of 30,000, what I'm going to do is I'm going to select the back face so I have a linear face that I can select from. If I go to press pull, I'm just going to put a box around all these edges like this. And it automatically grabbed all those edges, and now I can easily add and make them a 30,000ths radius and say OK. So you can easily put a window around and grab edges to be able to put fillets on really quickly and easily. Okay, so we're pretty much there. I'm going to turn this part and we're going to switch over to our CAM interface to be able to turn this down the way we want to see it in our machine. I'm just going to hide the origin to make it easier to see when we do our setup. Okay, you don't have to, but now keep an eye. So we have this timeline. As I had mentioned, if I go back in time before we had a fillet, we can always make changes. And if I go back in time, you can start to see the features start to shrink up on the browser as if they weren't even created yet. So it's easy to be able to go back in time, make changes, and pull those changes forward through time. I just want to show you that's the flexibility of working with our timeline in our interface. Okay, so I'm going to shrink up the browser, and what I want to do is I want to switch from our model space down to our CAM workspace because I want to make this on our lathe. So as I work through, we're working in a model space. Just to show you, we have these other workspaces that come with Fusion. There isn't any module that you have to download. There isn't any add-ons. You can work with your surfaces. If you do a lot of surface work and working with your wireframes and putting surfaces on, you can have the patch workspace to work in. If you want to cover holes in your models, you can easily do that here. Sheet metal. If you work with sheet metal, this is newly added last month into Fusion. It's an amazing workspace to make your sheet metal parts really super easy and robust. Rendering, full ray tracing, so you can get a photorealistic version of your part or assembly, and you could share it on your website, you could share it with your customers, your clients, put it on your Instagram channel, and quickly be able to make those photorealistic views of your part. Animation, if you want to show off how your design works, your assemblies, to be able to show inner working parts quickly and easily, you can make your animations here. As far as simulation, this is our Nastran solver that works inside of Fusion, where you can do and test for the robustness of your design. You can do stress-strain analysis, fluid flow, and a lot of those tools that you can do inside of simulation to check to make sure your design is going to be robust. We're going to spend some time here in CAM, but also we can, of course, make our drawings that we need. If you have vendor drawings you're trying to make, or even for customers, you have all those familiar functionality that you're used to if you're used to working in a CAM system to be able to do your drawings and dimensions and section views. So let's go into our CAM workspace. So I'm going to click over, and our ribbon bar changes over to all those functions we need to be able to use to be able to machine a part out. So, and we also, our ribbon bar, or shall I say our browser, switched over to our CAM interface, but we can always get back to our design, expand down, and we can get to those sketches we need. So if you want to choose geometry from a sketch to machine and bodies, you can always expand this down and always get back to your CAM component, or I'm sorry, your CAD component without having to go through another workspace. So in the setups, we're going to set this part up the way we want to see it on our lathe. So I'm going to go into setup. The first thing we do, working from left to right, is do setup. And again, as I hover over, I get that in-context help. I get the manual right there when we need it. So I'm going to select setup. And now it's set up as if I'm going to mill this on a, let's say, a milling machine, right? So it has a cube. I'm set up for operation type milling, and I can easily set that up if I want to try to mill that out, which would be interesting, but we could. But just to let you know, the same workflow that we're going to follow works if you're in the milling interface, if you're in the turning interface, or if you're doing cutting on your water jet, laser, or plasma machine. So we can easily switch over to turning mode. When we do, it gives us the information needed for being able to turn. So we can do turning or mill turn if we have any milled faces. If we're doing live tooling, we can easily set it up. We can choose whether we're working on our primary or secondary spindle. Our radial dimension mode we can work on. If we're doing diametric mode, we can do that as well. So the first thing it wants to know is, where is my radial axis? But because rotary axis, because I drew this part up initially with the sketch that revolves around the XZ axis, I don't really have to choose that. It's automatically in the model. But sometimes you might import a model or draw one where the Z is in the opposite direction. You can easily select any face or any edge that's revolved around that rotary axis. Like I could select this tube face and it would select that to be my rotary axis. That's the center, revolves around my Z. I didn't have to, but I just want to show you that we could do that. We can also flip the x-axis if we need to, just so you can have your part match the way that you set it up in your lathe. Okay, so I also, if you have any features that cross the XZ plane, like if you're doing any cross drilling or live tooling or any features that's going to cross that plane, I recommend making a spun profile. Just check this, and what it does internally, it makes a profile of the features that are completely on the edge of the part that rotate around that aren't affected by those cross features. So it's a way that you can turn, and it'll use that turn profile to do all the two-axis work, and then when you go to switch over to live tooling, it doesn't interfere. So you won't see those interferences. So we can leave that on. We can make a spun profile. I often turn it off if I'm only doing two-axis because it's a lot quicker in your toolpath calculation. So we can do that. We can make a spun profile. We can also set up the chuck. But I'm going to come back to this. I'm going to change my stock shape. So in the stock shape, we have flexibility on the way you set up your stock. Often I like to do a fixed size box where I can just plug in the dimensions. I can say my width, I'm sorry, not box, fixed size cylinder. So I can do my width, my stock diameter. I can say if my stock diameter is going to be 3 1/4, I can easily plug that and I can see that's my bar stock dimension right there. If I want to do my length, let's say I'm going to make this 4 inches. I would actually probably do 4.5 inches. And now it's from the center. Put the part right in the center of that stock. I'd like to leave 100 thousandths between my front of stock and the front of part. So I can easily change this offset from front and add 100 thousandths that we're going to take off. Sometimes you want 50 thousandths or 25 thousandths, but I'm going to leave 100 so we can see it clearly. So I put 100 thousandths. I have some room in the back. Now if I switch back to the setup, I can see exactly where my chuck is going to be grabbing onto the part. And this is good because I want to make sure my toolpath doesn't come in and my tool holder doesn't hit the chuck. So at least I can now have flexibility from my origin where my chuck is going to grab onto. I can plug those numbers right in here, and I can say negative 0.75, and now I know at least the back from the part, model back, that from here back I have 3/4 of an inch. So at least I can control exactly where the part is in the chuck so I don't end up crashing into it with my tool. Okay, so I'm setting up the chuck. Our stock looks good. Again, some flexibility. If you guys are ever working from a cast or a near net shape, maybe a forged part, you can have that in this part as an assembly and select that solid out, and that becomes your starting stock. If you're working from an STL model, that'll work as well. You could choose an STL to become your stock, which helps with secondary and tertiary operations. So I'm going to leave this as a fixed size cylinder. I'm going to say OK, and now we're ready to start turning. Okay, so now the first thing I want to do is I want to face off that 100 thousandths off the front of the part. So I'm going to go up to my turning toolpath, and again, if I hover over, I get that in context help when I need it. So I'm going to do a turning face. There's the operation. So I select turning face, and what I love about our cam, it's always the same workflow, working from left to right. No matter what toolpath you're working on, whether you're milling or turning or drilling, it's always the same workflow, working from left to right. Selecting your tool, your geometry, your radii, which is your heights from the center out, your passes, and linking. So I'm going to start with a tool, working from left to right, top down. I'm going to select the tool out of my library. I highly recommend creating a library of the machines that you're working on. So I was working on the Haas ST20 at Pier 9. So on the Haas ST20, we just filled in what was on the turret. So I highly recommend doing that, or you can also fill in what's in your tool crib as well. So select, it's easy to create a library. Just right-click on the library, go to New Tool Library, and I can easily make a new library and start to add tools to it. So if I wanted to add a new turning tool, I would just simply go up here and add a new turning tool. And now I can go and I see the standard ISO insert information, and I can choose the standard ISO insert that I have in my catalog, what's in the machine on the turret. The same thing for the holder, standard ISO holder information that I can plug in. So I can quickly get a tool, whether it's an axial tool or radial tool. So I can change the orient. If it's an axial tool, I just simply make that 90 degrees. In this case, it's a radial tool. And then if I go into my feeds and speeds, I can turn on and I can set up the feeds that I need for constant surface speed, as well as your feed per revolution. So you can plug in your values directly here, put in the tool number, and then of course turn on how you want your coolant to be on as well. Add a comment and OK, and that quick we have a basic turning tool that we can use to turn down a part. I'll select that one out of my new library. I'll say OK, and that quick, it gave me a face toolpath. I can see that it's going to face that off. I didn't have to select any geometry. It recognized off the model how much material we left on the front of the stock, and it knows where the front of the part is. So I'll say OK, and now I have a turn face profile. So I want to see what that's going to look like before I move on to the next step. So I'm going to go up to Simulate. While I have face highlighted, go up to Simulate. Move this over so you can see it. And I'm going to simulate this part. So I'm going to start to play, and I can see it simulate right on my part. Now I want to see it as if I had stock on it. So I'm going to rewind that back to the beginning. And now I'm going to go to stock. And now I can show it. It might be a little dark on your screen there. I could probably look at it this way. And now I can play through and watch what it's going to do down to the front of the part. So it's right on my part. I don't have to leave this environment, and I can see what that simulation is going to look like. If my holder hit the stock or hit the part, I would see a red highlight down here telling me where the collision was. Now I'm looking at that. As I look at it, I'm going to grab a hold of this view. I'm just going to click in the graphics view and drag it back. And I can actually go back in time, and I can go forward in time. It's taking two passes at 50 thousandths each. Now I'd like to make that 4 passes at 25 thousandths. So I'm going to go back and make a change real quick. So I'm going to close out of here, right-click on the face, edit, and in the passes tab, I can easily change that step over. The passes is where we're engaging the material, and I'll make that 25 thousandths per pass. Notice it updates live, right in my graphics view. Visual confirmation that I'm making this multiple passes. I don't have to edit in a big box, and hopefully it's going to look right, or it's going to work right. I can see it right here. So I'm going to make that 25 thousandths. I can see it's going to do those 4 passes. I'll say OK, and now I have that face toolpath updated that quick. Super easy to work with. So let's use the same tool, and let's get a profile. Let's profile all this out. Let's rough that out. So I'm going to go up to turning profile, and I can use the same tool. So I'm going to go in, again, the same workflow. I'm going to select that same tool out of the library, in fact, the one we created. And now in my geometry, I can choose, and also brought in my feeds and speeds, but I can choose out of here if I want to contain that toolpath. In other words, let's say I only want it to go up to this face right here. So I could choose, instead of having it go to the model back, I can select this face, and now it's only going to rough to that face. So in the geometry selection, it'll do the whole model, but you get a chance to confine it to a specific area you want it to go to, adding that flexibility. Also, because I have rest machining turned on, it's going to recognize that we've already done the face operation, so it's not going to try to cut through that same stock. So for now, I'm just going to say OK, and I'm going to show you that it's going to cut right till it gets up to that face, and then it leads out over that edge. So it recognized on the model that it's going to lead out over and clean that off for me. But when I wanted to contain it from the front of the part back to that face, that wall right there, that's where it kept the containment going. So if I right-click and I want to edit that, I want it to go past the back of the part. So when I part it off, I'm not cutting through all that raw stock. So I'm going to edit that toolpath, and in my passes tab, in my geometry tab, I'm going to turn this back to model back, and I want to do an offset of a -1/4 inch. I can see it graphically that it's going to take the tool past the 1/4 inch, leaving room for my parting tool to come in here and part it off. So I'm not cutting through all that stock. I'll say OK, and now we have that rough pass going all the way back 1/4 inch past the part, so we can part it off easily. So I want to change this. I'm going to soft click the profile one name. I'm going to call it rough. There's my roughing pass. If I want to change the step downs in here, if I want to have a little bit less of an aggressive roughing pass, I can edit. In passes, now I can choose my step over here, and then my maximum roughing step down. So I can change this if I want my step over. Let's say I want my maximum roughing step over. I'm looking at 50 thousandths is fine. I can easily change that. I can also make my step over 50 thousandths. I can also choose to leave some stock. In this case, we're leaving 4 thou on there. Let's say we leave 5 thou of stock on the walls and on these walls and on the floors there. And I'll say OK, and now I'm going to come back and do a finish pass, and you can see it's going to leave some stock. So let's take a look at that. I'm going to go up and simulate. So I go to Setup. I'm going to go up to Simulate. We've already seen it do the face, but we'll watch it do those 4 steps into the face. And now it's going to start to do the profile. I like to look at it from the back view, so I'm going to click the back, and now I can watch it as it roughs out that profile. I can even see it transparent, so I can see the model inside and get a good idea of how much stock I'm leaving on there and how much I have to remove. So that's looking pretty good. I'm able to see the part inside. I made it transparent. That looks okay. And now I want to do a finish pass on there. So I'm going to close out of here. So now I'm going to take that same rough toolpath we did, right-click, copy, right-click on Setup, and paste. And I have a duplicate of the same rough toolpath. I'm going to make this one become our finish toolpath, so I'm going to soft-click, call it Finish. Now I'm going to edit that toolpath because I don't want to use that roughing tool. Again, the same workflow, working from left to right. I'm going to select the tool. Now I'm going to select the finishing tool, and I can create one really quickly, but I know I was working on my Haas T20. That's got a good tool, and I'm going to borrow that in this new machine. So I'm going to go into the finishing tool, this number 2 up here, my 35-degree finisher. I'm going to select that, brings it into the graphics view. I can see it. I want to use that to finish this profile. So in my geometry, I'm not going to change. It's going to keep that same 1/4 inch behind the part. It's still going to look at rest machining, so it's going to see the previous operation, which is our roughing operation. I'm not going to worry about radii right now, but I don't want any roughing passes. I don't want to leave any stock, and I can also add a specific finish feed rate that I want to. I can also add multiple step overs for the finish. I'm going to leave it the way it is. I'm going to say OK. Now we get a finish pass. Okay, I'm recognizing that we're getting close to our time for the end of the webinar, so I'm going to do some grooving, and then we'll do some internal stuff really quick. So let's jump into grooving. So I'm going to go up to Turning, Groove. Again, the same exact workflow. I'm going to groove this area in between here. So I'm going to select the tool, and now it filters, but see, it's filtering on those tools that we're using here. I want to go into my Haas ST20, and I want to filter on groove tools. So if I go to type, go down to grooving, and now it's going to filter down on tools that make sense for grooving. So there's my square groove that looks pretty good. Again, I can edit it if I need to. I can always go in and see the insert, make changes to the insert, the holder, the setup. I'm going to leave it the way it is and select it, and I get this groove tool. I can see it in the graphics view, and now in geometry I can tell it, instead of trying to groove all these places, I simply want to groove from this edge. I'll go from this edge right here, and I want to groove back to this edge, right? So I'm going to go to selection, groove to this edge, and I want to keep the groove tool there and lead out over those two radii there. So I'm going to say OK. Before I do, in our passes tab, I can choose whether we want to do a full step down, partial, or even go sideways in between the groove. This is a pretty big groove, so I don't want to put the deflection on the tool, but if you have smaller grooves, you can easily go back and forth like you're profiling. So up and down, I'm going to choose only down because I don't want to go up the walls and hit the back of the tool before the material's been removed. And the same thing for my step overs. I can do multiple step overs. We'll leave the roughing passes on. I'm going to say OK, and we get a groove tool path. Okay, let's do a quick simulation. Now, I've already seen it do the rough, the face, and all that, so I can easily do this. On my browser, I can go down and select the finish, go down and select the groove. Notice the part updates. As I select each of these, it automatically runs through and shows me. I actually have some collisions there. I'm going to have to go and take a look at what I did with my tool. That's okay. So I'm going to show you what the groove looks like. So I'm going to go to, not close that out. Sorry, guys. Go back up. I'm going to go to simulate. And again, we're going to fast forward. Another way to do that too, I'm going to move this over so we can see a little bit better. Instead of going on my browser, I can also right-click and say next operation, and then next operation. And I can play through and show you what that grooving is going to do. And we can also do this as a peck. If you want to step down, we also have features where you can go in here and do that as a peck if it's taken off a lot more material than your tool can handle. So that looks pretty good. We're almost there. Let me close out. So what I want to do is I want to drill out this 3/4 inch hole, and then I want to use a boring bar to bore inside of here. So I'm going to walk you through those steps. Okay, so the first thing we want to do is just do a simple drilling operation. The same workflow, except we start and end on cycles. We don't need the passes and linking here because it starts on a G80, ends on a G80, starts on a G81, G82, and so forth. So I'm going to select a tool. Forget what the hole size is. If I hover over, I get the feedback, oh, it's a 3/4 inch hole. In fact, any of these diameters that you hover over will give you the diameter of the hole. So I need a 3/4 inch drill. So in my library, I go to select. Okay, I'm going to look for, let's say in my Haas ST20 drill, I have a couple 3/4 inch drills, and I can always filter on dimensions if I wanted to. So I know I only have a few here. Just want to show you that you can do that. It'll filter down on all tools that match that dimension. So I'm going to select that 3/4 inch flat drill that I'm going to have in the on the axial tool on my turret. I'll select the geometry. Now, I want to select this hold face, but this is important. I selected that face, but if you notice, the yellow is showing me my lead in. The green is showing me in blue. It's showing me where it's going to start to feed. It's actually blue. Now, I don't want to feed into my stock. I haven't removed this material yet. So be careful if you do that. Select holes that are inside of your part. Here's what you want to do. If I go to the Geometry tab, actually no, not the Geometry, the Heights tab. Now, it tells me here, so my clearance height, that's where I can safely retract height. My feed height is at the top. But notice where the top height starts at hole top. I want to make sure I change that. I want to change that not to be hole top, but I want that to be model top. So then it will recognize that I want to start in right where the model starts. Now I'm going to lead in and then start to feed into where I still have stock material. I could do the same thing on the other side. I'm going to leave that. I want to make sure it drills the tip of the tool through the bottom. So if I go down to drill tip through bottom, I can see that I can add an offset. I can give it a breakthrough depth, let's say a 1/16 of an inch, and I can see it's now going to break through the back of the part. You can see it graphically, so that graphic confirmation that it's going to drill all the way through. Okay, so that looks pretty good. My cycles, I can do peck drilling. If I did chip breaking, I can choose the peck depth, the accumulative peck depth. It'll give me that code. I'll say OK, and now we're going to drill that out. Now I want to bore this section. I want to use a boring bar inside of here. So I'm going to switch over to turning profile. And this is one place where we get a lot of questions. A lot of people who are working with internal boring are asking how to set this up. So if I go to turning profile, notice that it wants to do an external profile tool. So I want to use a boring bar to get inside to bore this area out. So what I have to do is on my tool step, I want to go down here and I want to say instead of the turning mode being outside profiling, I'm going to change that to inside profiling, and it drops the tool to the center line. So it now knows we're working from the inside out. We're inverting the way that we normally work on the outside in. So it selects that. Now I want to select a tool that makes sense for inside profiling. So if I go to select, I'm going to turn off this diameter. If I go down to my Haas ST20, I have a boring bar in here. We can easily set one up really quickly too. So if I go to filter, I want to go by type, and I want to go down to tools that make sense for boring. Now you can do this out of the samples library as well. So if you go to the samples, it'll filter down on tools that make sense for boring. It looks like I probably only have one in my libraries. That's okay, we can create more. So that happens to be the one that's in my Haas ST20, and that's a boring bar. So I can easily go in here and edit, and I can see what that boring bar looks like. I can change the holder type. I can change the insert type for that boring bar. And of course, in my setup, it's an axial tool. So I'll select that boring bar, and it gives me a preview of what the bar is going to look like at the center line. Now, for my geometry, I can tell it, I can have that boring bar go all the way to the back of the part. I don't really want to do that. I want to have the back, I want to select where I want the back to be. So I'm going to go to selection. I want to choose this face right here, and that's as far back as I want the boring bar to go. Now I could go all the way through the part. There's no problem with that, but I've already drilled out that 3/4 inch hole. There's no need to go into that hole like that. So I'm able to limit the distance for the boring bar. Now, here's the important part, the radii. I want to work from the inside out, right? So I want to have the minimum clearance, and I want to work from the inside out, not from the outside in. So I'm going to work from the bottom up. Now my retract and my clearance, this is as far away from the part that I can be. So my clearance, I want to make sure I'm at least well within that 3/4 inch. So I don't want my tool to hit before I get in there. So I can easily set this to a diameter. I know my diameter is a 3/4 inch hole, so I can easily set this by 0.7. So now I know I have 5 thou between where my retract height's going to be and where I'm going to start to feed in to that yellow area right there. So it's a quick way to be able to control. Now you can also select geometry, but I like to control it by diameter. And this gives you more control over the retraction. So my clearance, I can easily do that too. I can say, I want to make sure I'm clear, and I want to be able to go 5 thou below that, so I'm going to put 0.65. So now my clearance is going to come. I can make that as small as I need it to be. I can make that, a 1/2 inch in diameter, as long as I'm not crossing over that center line. So that's as far as I'm going to be clear as my part retracts, or my tool retracts out of the material. So the next thing I want to do is my inner radius. Of course, I know that's going to be 3/4 of an inch. And now my outer, my stock OD, is going to be the furthest out I want the boring bar tool to hit, which is that face right there. So I can easily select that. I can say selection, I'll select that face, and now I'm working from the inside out, my smallest clearance, all the way out to my widest outer radius. And now if I hit OK, I get an internal boring operation. So now I'm working from the inside out. I can see my retract's going to be off of my stock, and I know where I'm going to start feeding is going to be only in the material that's left. So work with diameters. You don't have to. It's just the way I like to work. And you can always use the geometry that you're working with as well. Okay, So we're at the top of the hour. Hopefully you guys are able to stay with me for a little bit. It does look like we do have a question. Can you dimension in diameters rather than radii? Yes. Yes, you can. That was Ed had asked a question. Yes, you can dimension in diameter as well. You just have to set that in your setup initially. Okay, so real quick, I'm going to make a super fast change. We're going to get some code out. So let's get some code out using these profiles. So I'm going to go to Setup. I'm going to Post-Process. Today I'm working with my Haas ST20Y. So it looks like I don't have a post in here for the Haas ST20Y. You can easily do a quick search on our online post library. So you just click this little link here, and I can filter on type for turning or mill turn, and I can find, there's my Haas ST20, ST30Y, and I can download those directly. I can even see a sample of that code really quickly, of what the code looks like and what I can expect. So I can download that, and I would do that, download and add it to your personal post folder. If you're going to make any changes, I highly recommend use your personal post folder. That's where I downloaded it to, and I can easily switch over, and there's my Haas ST20Y post. So let's post out for that machine. I'm going to go down here to post, save that file, and overwrite one that I did earlier. Give it a second. It's going to open in brackets, and now I can save this onto my thumb drive, bring it over into the Haas control, and start running this part right now. But I just realized something. It's the wrong part. I just got an update on my napkin sketch. I just realized that the team we're working with to prototype it has to make a couple changes. So we're going to go in, and I'm going to show you what those changes would look like. So as I switch over to the model workspace, I can go into the sketch we use to make the profile, and I'm going to make a few sketch changes in here. So my outer radius part here is going to be 0.875. My inner radius is going to be, this is going to be a half of an inch. Actually, we're going to make it a little bit bigger. We're going to make that 3/4 of an inch. We're going to make the depth go a little bit further. So we're going to make this depth is actually going to go in an inch. So we're making some pretty major changes here. And my overall diameter of the boss right here is going to be 1.25 inches. Okay, we're going to stop that sketch. We made some pretty significant changes to the part. Okay, I'm going to go back into the cam. Notice all of our toolpaths are now red. So we have this red circle with exclamation point. Our face looks good, but our rough is going to go right into the part. Our finish, our groove looks okay. The drill and our profile is not going to be big enough. So we made some major change. Now if I go into Setup, right-click, Generate Toolpath, or hit Control-G, it automatically updates every toolpath to the geometry changes automatically. We don't have to go in and reselect anything. Any changes we make, it automatically updates and recognizes on the CAM side. So complete integration between the CAD and CAM side inside of Fusion. All right, so we were able to cover, we walked through how to draw up a part really quickly. We were able to model it. We made some revolved base, and we revolved some cutouts. We saved the part. We added some fillets in here really quickly by direct editing. We came into the CAM side, and I showed you how to set up those toolpaths to be able to turn apart a simple part like this, including drilling and internal boring. And we were able to get some code out for the machine. We made a change and saw that change happen instantly. So now I'd like to go in to update that posted code, save it, and now I have the correct part that quick that we can now run that prototype in the machine. Super fast changes you can make in the CAD side, updates on the CAM side, really easy to use. Each toolpath has the same workflow. Really super easy to learn and easy to use. Okay, guys, looks like we don't have any more questions. I know we're a couple minutes over. Thanks for staying with us, and hopefully this has been helpful for you. Please tune in every Wednesday. We do these basic trainings, and every Friday we have more advanced speakers with us to walk through some advanced tools. So join in next Wednesday if you want to see more on 2-axis to 3-axis turning, or milling, 3-axis milling, to be able to cut apart like I showed you earlier, make a vise, make an assembly, bring a part into it, and be able to cut it out using that assembly and putting toolpaths on, and show you how to make templates as well. So guys, hopefully that's been helpful for you. getting started with turning, using our interfaces to be able to get your Toolpaths going. So guys, thanks for joining us, and we'll see you next week.